Good afternoon, everyone. This is Jonathan Hernandez. My apologies. I will be reporting from home today, so I pre-recorded this for y'all. Dalen and them will be running the meeting, and the other officers, but we're very glad to have you guys. So as far as Power and Energy Society goes, I will give the small spiel as normal, and we will be glad to introduce some of our projects that we have for you. Some of them have very quick turnaround times, so we would like you guys to be involved, and we can do multiple iterations of these, but some of these, we can only create one or two of them rather than giving each person their own. So, Power and Energy Society. For anyone who is new or does not know about the organization, we are dedicated to introducing the field of power and energy to you all as you are in your younger years of your degree. So, one thing about UTSA is you're not able to take power courses like power electronics, power engineering laboratory, or any of the upper divisions. We only have really 3 or 4 courses for power, and they rotate in and out. So, sometimes they're not even available. So, we want to expose you guys to this as well as help you build kind of fundamental topics for circuit design as well as components. So Power and Energy Society focuses within 3 main areas, which is power as it affects our world, which is the less technical part of the organization. It's how do we get to a more sustainable future and what technology do we use to get there? And there's also power management. So how do you actually send power and regulate voltage and current, as well as send power within a city or even at the device level? How does your circuitry operate? And we have programming in power, which is how do you prototype devices to utilize within power circuits or for your own personal projects. So we do have our Instagram, our Discord, as well as the YouTube. I'm posting this video to YouTube. It's still kind of cringe, but hey, that's a-okay. And if anyone wants to join, the group me is right here. So I will give a few seconds for anyone who needs to pull out their phone to go on and get on the group me if you're interested as well. And moving on. So as far as our organization goes, we have no dues. We are a hands-on organization. We do not want your money. One of the things that we do have is a digital membership card that we'll be pushing out. If you are a first-time person here and you would like to sign up for the organization, go on and click the sign up. If you have joined the organization, do not sign up again. So you only fill out the form once for sign up, and then every subsequent time you use the check-in form so that we can accumulate your hours. So this is just how we track your technical hours contributed to the organization. This we use in instances of, say, we want to check your activity or reward some of our members or have exclusive events, and we will end up utilizing this. Then we also do have a hands-on portion of our workshops that we let people take things home with them. So we will be using this as well to track attendance as well as see what we want to budget for in future workshops and just kind of run statistics on it so we can budget for the amount of students that we have. So I'll give you guys just a few more seconds to either do your sign up or your check-in. If this is your first time, go on and do your sign up, and then you will have to do the check-in as well. If this is, your second or whatever time you've been with us last semester as well, just do the check-in. And y'all can pause the video if you need, I promise. And I will continue on. So as far as the organization goes, some of the things that we have done are spot welding of battery packs together. We talked about runtime of batteries as well as how to do the calculations. We did a solar panel workshop where Jonathan Cameron, our resident solar expert, had decided to take us outside one day and show us how these work, setting them up within series and parallel, as well as we got to connect someone's phone. Justin Moreno was nice enough to let us on our first time connect his phone to it, and it did not explode. So that was a wonderful thing. We've also done workshops. The third picture is when we do our intro to power. So we assume that you guys really know nothing, and we just want to take you through the ins and outs of it and train you as if you knew nothing, just so that everyone's on the same page. We do have stoles for anyone who is a junior officer or officer and has committed to our organization, and this is also available for people within other societies for their service. Then we also do SMD soldering and boards as well, and then also training on how to mount the SMD device components like the kinds that are inside your phone and your laptop. So the project that I'll be presenting on and I'll be running is a high voltage project. Ideally, what it is a Jacob's ladder. So we will adjust this because we do want to talk about some more concepts, but it is not just high voltage running through 2 wires in this project, like normally what Jacob's ladders are. In this case, so what you'll see depicted here is there is a transformer right here that steps up voltage to a super high level. So we might cannibalize some microwaves to go on and get some bigger transformers out of it. But ideally, we would like to, and I believe we can stick to budget for this, is provide every person who's interested in the project their own small kilovolts transformer that they will assemble, similar to the one that I've shown within our last workshop, and then also be able to send everyone home, hopefully with a miniature version of this, but we still want to create the bigger version. So ideally, a Jacob's ladder is you step up voltage to a super high level within the 10 kilovolt to, even if you want to go up to 400 kilovolt area, and you pass it between two wires. One is charge negative, one is charge positive. And from there, there's a breakdown of that dielectric constant in the air, as you can see within the next picture right here, is it's actually ionizing the air and creating plasma and jumping. So this wire was not able to sustain the actual damage from having that high potential voltage. So you'll see kind of some of the film or some of the protective coating is burning off. So we will account for that. This is a high voltage project. There will be waivers of liability, but ideally we do want to show you the control circuits and show you some pretty cool things to this. So the materials list for the smaller version that we hope to send every student home with after they create their own is really a high voltage transformer. So we will either, similar to the PCB one that I made, we will utilize those, a high gauge rigid wire that will stand in place, that can stand the amount of electricity we're going to pass through it, a 3D printing filament so that we can utilize that to actually 3D print bases, a mason jar to contain it so that it doesn't arc and shock you, and then some gas that is used as a dielectric. So an example is we spoke about capacitors, and one of the things is capacitors have a material on the inside of them that is known as a material that causes a dielectric between the two plates. So then whenever you have that, like in this case between the Jacob's ladder, air is the dielectric. But in your capacitor, you might have like some insulation that's acting as your dielectric, or in the case of like a transistor, you have a semiconductor like silicone acting as your dielectric. And it's really just some material that has a dielectric constant, and when you pass current through it and electricity, eventually it'll break down. So the higher the dielectric, then that means that it's an insulator, and the lower the dielectric, the more it'll be a conductor. So the dielectric strength really is a material, and what happens is the material measures the ability of that material to withstand the actual voltage differences that you have. So then if the voltage across the dielectric exceeds what the dielectric constant and material can handle, then it'll start to pass charge between the plates. So it'll arc, it'll jump. Real life dielectrics that you have seen and worked with and seen explode are capacitors. And that is just one of the principles behind them. So this also helps us reinforce the principle of capacitors and dielectrics. We have spoken with the physics department of UTSA, who's very interested in this project and wants to know more about us doing it, because dielectrics, especially when it comes to gases, have applications within space. So if you use high voltage within the International Space Station and things like that, well, how does electricity propagate, and what are the dangers to having a low pressure or different gas mixtures such as nitrogen, oxygen, and things like that within the International Space Station? So then an example is right here, we have electricity passing through different gases. So in this case, this is helium right here, neon, I know you guys can read, but I'm just reading for you, krypton, xenon, and argon. So these will not combust whenever you pass electricity through them. So ideally what we want to do is take Jacob's ladder a step further and start doing measurements of pressure and the amount of electricity that passes through given the dielectric constant with this, as well as change the gases in there to, you know, get a nice pretty light show. But that's just some of the examples. It's essentially a cathode ray tube kind of experiment for those of you who know what that is. But if not, don't worry, we will walk you all through it. Then this is hopefully what we want the finished product to look like, is just a small base that is 3D printed, a button on it. You have your two wires that are rigid enough, and then you have the gas inside contained by the mason jar, and it's able to arc above. So we would love to have you guys join on this project. This project is a very, very quick turnaround time. So we do hope that you all will join and hopefully enjoy it. The cathode ray and the bigger portion of this that we do, so if we decide to take a transformer from microwave, that one, we will only do one run of that one, but the smaller ones we hope to send students home with. And just kind of on my end, before we go on and go to the next project, I would like to make two announcements real quick. Is we have won the Tier 4 HSI grant, so we have now $1,000 to utilize for a workshop or in some way professional development for you guys. So for everyone who joined, thank you so much. We were able to achieve that, and we actually had a lot of members join in on the same one. So we all kind of descended on Adobe, which was hilarious. So if anyone needs a recommendation letter, please reach out to us and let us know. This past week, we also went and tabled at St. Philip's for the See Your Career Day with KLRN, CPS, Itron at St. Philip's. And it was just a really cool experience for us to do. We got to help SAMSAT with their Sphero bolts, and they do have a graveyard of Spheros. So we have asked them if we can utilize those in some way since they don't know what to do with them. So in the future, we might do some electronic repairs and break down schematics in the future, but we'll wait on that, and we will in the coming weeks tour SAMSAT. So with that, that is the end of it for me, and you guys will continue to hear about the rest of the projects, but I hope you guys have a wonderful day and stick around to hear the next ones. Later, y'all.